Whatever happened to predictability? Now it's limits, derivatives, discontinuity. We're here to show you what it's like to be free. When you know calculus, everything is easy. Everywhere you look, everywhere you go, there's a function, a theorem to hold on to. Everywhere you look, everywhere you go, replace the differentiation's not that hard to do. Everywhere you look, everywhere you go, it's a function, a theorem to hold on to. Everywhere you look, everywhere you go, replace the differentiation's not that hard to do. Everywhere you look.
Hey girls, how's the math homework coming along?
Not too well, actually.
Yeah, calculus is the pits.
You think I can do it all?
Not unless you're Janine Logston, our Brill calc teacher.
Well, I may not be any dank math teacher, but I did know a thing or two about calculus in my day.
I mean, back when dinosaurs roamed the earth.
I'm serious. What are you working on?
I don't even know where to begin.
Well, here's what I know. Limits are the core tool that we build upon for calculus. Many times, a function can be undefined at a point, but we can think about what the function approaches as it gets closer and closer to that point. This is the limit. The derivative of a function f at x equals c is the instantaneous rate of change of f of x with respect to x at x equals c. The slope of the line tangent to the graph at x equals c is the graphical meaning. An integral is a mathematical object that can be interpreted as an area or a generalization of area. Integrals, together with derivatives, are the fundamental objects of calculus.
Wow, Joey, that was surprisingly helpful.
Hey pals, how's it hanging?
Hey Steph, I was just helping the girls with their math homework. I got a jet. Want to take over?
You betcha.
I'm having trouble with this problem about discontinuity.
Do you know the different types of discontinuities?
I do. There are removable discontinuities, step discontinuities, and infinite discontinuities.
Bingo, that's exactly right, DJ.
A function is continuous if it can be drawn without picking up the pencil, otherwise it is discontinuous.
Sheesh. Looks like someone is finally paying attention in class instead of drooling over Will Beaker. Hey!
If you two don't cut it out, you'll never get your homework done.
Alright. What's the next problem?
It says here, you have to find the derivative using the derivative rules. Oh boy, I hope you were paying attention in class.
Don't sweat it, Steph. First, you need to know the basics. If f of x equals c, any constant, then f prime of x will equal 0. And if f of x equals x, then f prime of x will equal 1.
Super, what's next?
Next, you need to know power rule. You take the original function, multiply it by the exponent, and then decrease the exponent by 1. Want to try?
Sure thing.
Start with this one. F of x equals 4x to the 6th.
Okay, so take the original function, multiply by 6, and then decrease 6 to 5 so that you get f prime of x equals 24x to the power of 5.
See, that wasn't too bad, was it?
That was easier than teasing your hair.
We're almost done, just a couple more problems.
Good, because Bobby is picking me up at 7 for the Bruce Springsteen concert.
Never get started. Uh-oh.
What?
You might be here for a while, Kenny. This one looks really gnarly.
Aw, rats. What does it say?
The fundamental theorem of calculus. That sounds harder than solving a Rubik's Cube.
Don't be an airhead, that's not hard at all. You'll be at that Springsteen concert in no time.
What is the fundamental theorem of calculus, anyway?
It's the theorem that tells you how to calculate exact values of definite integrals by using indefinite integrals.
Can you explain an example?
Yeah. The first thing you have to do is take the antiderivative of the original function.
I know how to do that. The antiderivative of x squared is 1/3 x to the 3.
It sure is.
Okay, what's next?
Plug in your limits of integration.
I got 21.
Bingo.
We did it.
Wow, calculus is no walk in the park, that's for sure.
Yeah, but when you have Janine Logston as your math teacher, calculus is the bomb diggity.